Welcome! Let's take a look at Meadow, a scattering toolkit I've put together for Houdini. To be clear, this isn't a total replacement for your existing workflows. The goal here was to create a set of nodes that seamlessly integrate into Houdini. You can drop them into your current setups to get an extra layer of control without having to change your entire graph, as they behave just like the existing nodes. In this video, we're going to walk through the different nodes in the kit. You can click the timestamps for each node and check out the description for how to install these nodes yourself. For this demo, I prepared 3 component builder setups. So these are just going to be the objects that we're going to be scattering so we can easily tell what is one. I got here a cube, a sphere, and a pyramid that I parented under this asset scope in the stage. Now, all of this is set up in the stage, but the nodes are all going to work on a sub level. So when we'll dive in to subs, I'll show you how all of that is set up. Let's go into this instancer here. I'm going to disable this for now so we have our ground coming in here. And then in the instancer, the first thing that we're going to do is we'll bring in this surface with up input path here with this expression where we're bringing the render purpose, and we're going to just import all primitives from this stage. We're going to convert that to polygons so we have a surface to work with. And then we're also going to bring in our assets just like this, but when we unpack them, we're actually only going to unpack them to components so that if we switch this to primitives here, we're getting the component names. If this is set to gprims, like the default, we're going to get the mesh names, which is not what we want for our preview. Then at the very bottom here, I'm just previewing, after we've done all our setup, I'm previewing the points with a copy to points, and I'm merging it with the surface so that we can disable hide other objects, and that way we only see the output of this, which makes it a little bit easier. So this is kind of like the setup that I'm going to use for this whole scene. This is our preview, and then everything that is going out is just going to be the points that is then fed into the instancer. Let's start with the Meadow scatter node. The Meadow scatter node just distributes points on a surface. So let's plug that into the surface, and then we can increase the density scale just like that. Now you'll see a pattern appear, and that is because there's a subtle difference between this node and the normal scatter node. It has a projection plane. We can show this projection plane, and what this does is it just projects UVs onto the surface. And by default, this generate parameter is set to in texture space. So if we compare it with the normal scatter node, it looks exactly the same. All the parameters are the same, except we have this show projection plane parameter, or this projection plane parameter here. So let's increase the scale on this so we don't get any repetition in the UVs, and we can increase the density scale up to, let's say, 10,000. And I'll show you what the difference is between this node and the normal scatter node. So to begin, let's take a look at the normal scatter node. I'm going to set it up exactly the same with a density of 10,000 or a total point count of 10,000. And let's take a look at the output. So with this one here, we're going to get a bunch of points on a bunch of cubes distributed on the surface. So far, so good. But what if we want to add something? For example, I have some changes in the geometry here that I want to add. A close-up ground maybe, and maybe this log, maybe a tree log. So what happens when I add that to our instancer? Everything changes. So as I toggle this, all these cubes back here, they change. And that is not very nice, because as soon as we change something in the environment, we don't want everything to change. Now, if we do this projection setup, and if we do all of that in UV space, let's take a look again. And if I toggle it, nothing changes. So all of these cubes here change because we have some changing geometry, but everything else stays static. So that is very nice for environments. Now, the other benefit is that in here, we're only projecting, maybe this is a little bit hard to see, but we're only projecting points onto the topmost surface. With the normal node, we're getting points all the way back here, but with the projection, we're only getting it on the top surface. So let me go to this mode here. So here we're getting points on top of the log, but not underneath it. While with the old node, we're getting a bunch of like duplicated points down here in the top and up on below. So that's not what we really want when we want to scatter grass. So let's use this Meadow scatter node for now. Now we can zoom out here and let me just look at the points again and show this projection plane again, because we can hit enter to get into this edit mode. And let me just show the side panel here so that we can see this as well. This is this mode. And I can move this around now to move the projection plane. If for whatever reason you might have a hill and you need to adjust this, you can kind of like rotate this projection plane as well, of course. Otherwise, this behaves exactly the same as the scatter node, and as for attributes, we're just copying all the attributes from the surface right now. If you want to limit that, you would come to this output attributes section. That's it. Otherwise, it's the same as the scatter node and it plugs in. Sometimes you might also want to use a scatter and align node. So all of these nodes are interchangeable. All right, our next node is going to be the Meadow cluster node. The Meadow cluster node is useful for, well, adding clusters. Let's visualize it and increase the size a little bit so we can see what's going on. It creates a really nice natural pattern with this Perlin noise compared to a Voronoi based clustering. So with this Perlin noise, we're also getting options like roughness to kind of like change how the pattern looks like. And what this is useful for is if you would like to scatter different colors of flowers, for example. So we have like 1, 2, maybe 3 different flowers. Maybe these blues here are hard to see, so you can change the seed on this on the colors a little bit, or you can obviously always put your own ramp in for the color visualization. Now, let's assume this is a field of flowers, and I'm going to just bring down the roughness a little bit to get a little bit rounder shapes. And we would like to kind of like blend some of these a little bit. So that's where the blur radius comes in handy. And we can just kind of like increase the blur radius just a little bit to have some intersection between, like some blending between these different shapes. Right now it's creating an index attribute that is an integer attribute. So if you hover over here, we're getting this index integer attribute. And if we would want to, or first let's take a look what that looks like right now. So right now we're not getting anything, so we can come to our copy to points here, and we can say on this piece attribute, we can say index, can type index, and we're getting our 3 objects scattered here. So if we would like to kind of like control this a little bit better with names, we can also come and change this to string and actually type in, cube, pyramid, and sphere. And that way, if I type in name, that way I can actually kind of control, like I want not a lot of pyramids. And if I come down to my copy to points again, I will obviously have to change my piece attribute to name. And now we're getting very few pyramids. I can't even see them, but here they are. We're getting few pyramids and the rest is just cubes and spheres. Next up is the point transform node. So let's put that in. And this node is useful for aligning the objects that we're scattering onto the surface. Without this node, if we take a look at the preview, the pyramids kind of like follow the surface pointing this way. And we want them to be standing up, pointing away from the surface. The reason why they're kind of following the surface is because by default, the normals, if we display the normals here, they're pointing up, obviously, because that's where the surface normals point to. Now, for scattering with the copy to point or with the instancers, the normal is actually the direction of the z forward axis. And if you look in the bottom left here, z forward is kind of like this way. So these don't really line up. We can use this point transform node and set this initial direction, which is going to, I'm going to just hide the normals again. It's going to line up all our objects to the surface. So that is great. We also, they're just following the surface. We also have an option to set this direction and move it to 1. And this makes it so that they point to the up direction, which you can set here or with the up attribute. This is useful for like a forest when you want trees to point upwards instead of following the normal. For us, let's leave it facing away from the surface, so following the normal. Next up on this node, you also have translation, rotation, and scale randomization options. You can, for example, rotate all these objects maximum 360 degrees, so we're getting full rotation. For buildings or something like that, you might want to add a step size. So now we're getting everything rotated in 45-degree steps. The objects overall are going to be a little bit too big, so let's scale them down, and this will set the p-scale attribute here. But it would be kind of cool to have some objects that are really big. So let's randomize that a little bit. By default, the lock ratio is set to xz. In this case, I actually want all axes to be locked, and we'll just use the first, the x coordinates here, to set a different scale. So that way, all axes get scaled evenly. This is cool, but now everything is too big. I only want some objects to be really big. We can use a probability ramp like this here. So I'm gonna choose that, and I want most of my objects to be kind of like 1, and only very, very few objects to kind of be randomized between this 1 and 4. So I can use this. Maybe I'll just increase it a little bit to get some randomization. And then I have to bring down the scale a little bit. All right. And so now we have some really big objects and some smaller objects. I'm going to take out the step size. And we can take a look at the last option up here, the translation. This really is just to kind of add some randomization away from the surface into the surface, or left and right kind of like randomization. The last parameter to talk about is going to be this randomness parameter, and this just controls the randomness for these parameters up here. By default, it's set to random with the seed attribute of the position, and this is again just to control the popping that we would get if the points the point order changes. We don't want any popping to occur. Now, if we need to be even more accurate, we can switch it to this noise, and this will use a noise-based randomization. We can visualize this noise, we just have to look at the points themselves. And if we increase this parameter, you can actually see the noise appear. This again is just so that if a point moves inside this kind of like noise, it just moves a little bit, that we don't get crazy popping if this probability curve here changes, right? So let's leave this back at random and take a look at this output. All right, so that is the point transform node. Okay, the next node is going to be the Meadow Prune node, and this node we'll put down right at the end here. And let's take a look at just before that. It will essentially blast any nodes by this attribute. Before we can use that, we actually need to create this attribute. If you remember, on this scatter node, we actually copy all the attributes from the surface. So let's just create an attribute paint node and put that right here after the surface. Take a look at this. We can hit enter and actually start painting, we'll have to show our visualization here. We can start painting some areas that we want to keep for our scatter. Now, red means keep, blue means, discard. If you want to show this mask when you're looking at another node, for example, at the scatter node, and you want to preview the mask, you can come to this visualization tab here and just click it. If you, for whatever reason, don't have this, you can delete it and create a new visualization. I'm going to set it to color. Name this mask. Name this mask as well. Leave this at color and set this to ramped attribute. Type in mask here. And then here, make sure to set it to min and max so that we're clamping and only showing values between 0 and 1. Then I'm just going to set it back to infrared and close that. Now we can toggle this at any moment. Now let's get back to the Prune node now that we have this mask attribute, and we're actually using this method again, the random method by position, to kind of like make it more likely for points to get blasted away. Again, we can switch this to noise, which is exactly the same thing. We can increase the noise and actually get some interesting patterns, or we can leave it at threshold, which is just going to delete any points below this threshold. I'm going to leave it back at random, and that's the Prune node that is going to allow us to just only scatter objects where we want them with a mask like this. The next node, the Meadow Frustum Cull node, is used to cull objects outside the camera frustum. It can be used to optimize heavier scenes or just remove any objects outside the camera field of view. So to get started, I have an instancer set up with a camera that I animated, and this camera just moves along here. Then we'll plug in our Frustum Cull node and take a look at that. First thing that we need to do is we need to set the right instancer, in our case instancer 6, and then we need to use a camera that exists in the scene, so in our case camera 4. And we get this Frustum culling just like that across this surface. Now we can give it some padding just to make sure we're getting areas outside the camera. So if we look through the camera, we're getting points outside the camera. And if we want to move back a little bit and simulate the camera being further back, we can just do that, which is also going to give us a little bit of safety in case we want some objects that are behind the camera. The last option that we have here is this limit distance. We can actually kind of like limit how far into the back we instance points. So if we set this to distance, I can bring this distance all the way back and kind of like have a threshold here to only show points 76 meters away from the camera. We can also set this to fall off if we want, let's say, to fade out points from 50 meters to 76 meters and just kind of fade out some points. Obviously, this is going to move through the scene just like that. The fall off might be better used for not for static scenes. This node is going to work in LUPs, and there's also a Frustum Cull node for subs. This is just going to work with a camera operator that will need to be pointed to a camera in an object network. Let's take a look at the mask nodes and start with the mask by curve node. The mask by curve node simply allows us to mask an area by a curve. So I have this surface and I already prepared some curves here. These are Bezier curves. And I'm just going to preview our surface so we can see both. And the Bezier curve, the nice thing about the Bezier curves is that they're really easy to kind of like, manipulate and change after the fact. So to get started, let's plug in the curve into the mask by curve, and we're immediately getting this mask area. Again, if you need to visualize the mask, come down here to the visualization or look at in the Prune section on how we set this visualization for the mask attribute up. once you have this mask attribute, the first thing that happens is we're going to get a warning about Bezier curves not being very fast. So to fix that, we can resample our curves here. So let me resample that and just set a maximum segment length of 1 meter, and that should increase the speed drastically. All right, let's take a look at this. We have a radius that allows us to kind of like add a fall off to our curves. We also have this offset that simply offsets if I preview these curves here, or I can also show the curves down here like this. The offset simply dictates whether the fall off happens on the inside or on the outside of the curve. So in this case, let me do it inside, and that looks good. If I would want these curves to rather be open curves, I could set this to open and then add some thickness. Obviously, I would have to adjust the fall off, but in this case, I like them to be shapes. Then we can stack these curves as well. So let me add another mask by curve node and plug in the next curve. Again, we're going to get the warning. So let me resample this curve as well, like this. And in this case, we actually want to exclude our curve. So our curve is just a road that kind of goes through this. And I can give it some thickness. And then I'm going to exclude it and give it a little bit of a fall off, just like this. And maybe I can play with this fall off here as well, so that we can see this road going through this area. And this is how we can really easily use curves to mask out some areas. And it works great with attribute paints and other mask nodes. The next node is the mask by feature node. And as you can see, there is already a mask by feature node. Let me use this mask by feature node. Whether you use this node or any other node like this mask by feature node, and you want to use this directions and shadows mode, it's totally up to you, because all these nodes do is they create an attribute that we then use with other nodes. So that's kind of like the beauty of this tool set. You don't have to just use these nodes. You can use them interchangeably with other nodes as well. So then the mask by feature node has two modes here, slope and altitude. And if we look at slope, let's just compute the range here. It gives us a range or a slope in this range here, or we can use it in combination, or we can just use the ramp only here. I personally like using the ramp only because it means that if I change the underlying geometry, this will kind of like behave the same. So I can kind of like mask out areas that are really steep, and I can also mask out areas in a certain altitude. So let's say I don't want any trees up here and only down here. Well, I would simply compute the range and use the range ramp node here and invert this here so that we don't get any trees up on the hill above this thing. Now, this is currently set to copy, so let's set it to multiply. So we'll multiply it with our slope. But the slope I actually also want to multiply so that we can keep our curves and some of the other stuff from before. So now that we have all of these working together, we can maybe kind of like fine tune that a little bit and bring the height up a little bit. Then once we prune it, we can then see our forest area that is excluding the slopes and this road that we have here. Now, when you use these kind of like masks, it's going to be really nice to use an attribute remap and create a p-scale attribute from the mask by simply remapping the mask, maybe to something like this. You can play around with this. Obviously, this is just the ramp here, so that we get some smaller trees where we have less density and bigger trees where we have more density. After the fact, I simply put a prune node down to prune out the trees that had no density, and added some randomization in rotation and adjusted the point scale. For the next node, the mask by geometry node, this one, we're actually going to use this hill scene here. So this is like a hill, and I already placed some trees on this hill. I would like some fern scattered on it, so I've used this scatter node, and what we're going to do is going to plug this mask by geometry to create mask from these trees. So I'm just going to plug that in, and this node works on points and on surfaces just alike. We get our radius attribute that we can use to adjust this mask. And this allows us to then again use an attribute remap and a prune to kind of like create these clusters around each of these objects. Now, there is a mask from geometry node. I just didn't like that all of the nodes had the by, except for these guys have mask from. And it's also a little bit slower, I found, on thousands or hundreds of thousands of points. Otherwise, this will behave exactly the same. So you can see this is really kind of like exactly the same setup. Again, all of these can be interchanged easily with each other. So use whatever node you feel like works best in your scenario. In this case, we're going to use this mask by geometry. And you can change the method here from distance outside also to distance from surface, which is going to give us just the surface, or distance on the inside to mask everything except for the inside. If you want a little trickier, if you want to not have anything on the inside, you can use a ramp and then just bring that in just ever so slightly and add a point, bring this down, and then you can shove this point all the way back, and now you have nothing on the inside. So if that's something that you need for your setups. The last node is the mask builder. The mask builder node, if you take a look at it, it's just a bunch of noises stacked on top of each other. So by default, we're starting with a Perlin noise, and I'm just going to increase the scale here a little bit so we can see what we're working with. And then we can use this ramp attribute to adjust our Perlin noise, and it has all the normal noise settings, such as this roughness slider. And the nice thing about the scale is the larger the scale, the larger the noise. So it's not inverted like most noise parameters. Once we're happy with our Perlin noise, we can add another noise, and let's set this to Worley, for example, and kind of like adjust this a little bit. Let me add some more contrast here as well, and maybe actually invert it to get some of these circle shapes. And now I want to multiply it. And as I'm changing the scale, you can kind of see how we're stacking these noises on top of each other. Now, the beautiful thing about this node here is that we can just go through presets that I created to kind of like look at some of these setups. And this should allow us to really quickly build some setups for our scattering. This case, I'm just going to use one of these scales setups to add some patches. Put this into our in here, and then we should have our little grass patches here. This is going to be the spheres. All right, these are all the nodes that we have so far in the Meadow scattering toolkit. Feel free to leave a message below or create an issue on GitHub if you run into any problems. GitHub is also the place where you can download all of this stuff and where you can find the installation instructions. You'll find the link in the description. Thank you for watching.